of you joining us today for tutorial 3 of the International Conference on Artificial Intelligence and Data Sciences 2025, organized by the Sri Lanka Association for the Advancement of Science, in collaboration with the Southeastern University of Sri Lanka. Today's tutorial focuses on basic ontology development, foundations, tools, and applications, a fascinating and essential topic in the era of artificial intelligence and data-driven systems. We are delighted to have all our distinguished guests, speakers, and participants with us for this exciting session. To officially commence today's tutorial, I would now like to warmly invite tutorial session coordinators, Ms. Sana Latif, Senior Lecturer, Department of Computer Science and Engineering, Southeastern University of Sri Lanka, and Dr. Pasan Maduranga, Senior Lecturer from the Department of Electrical and Electronic Engineering, University of Sri Jayewardenepura. We would like to invite Dr. Pasan Maduranga to introduce the tutorial session speaker, Dr. Kaneeka Vidanage. Over to you.
Yeah, thank you. I will formally introduce our speaker today, Dr. Kaneeka Vidanage. Dr. Kaneeka Vidanage, currently the head of the department and the senior lecturer at the Department of Computer Science, Faculty of Computing, General Sir John Kotelawala Defence University. Dr. Kaneeka has over 15 years of experience in teaching and research at the industrial level. Dr. Vidanage holds a PhD in artificial intelligence and has published extensively in the areas of knowledge engineering, personalization, learning system, and AI application in healthcare. He has also conducted numerous workshops and tutorials on ontology engineering and semantic web technologies. His current research focuses on ontology-driven personalization in e-learning and AI for digital health, reflecting in continued committed to advancing intelligent, human-centered computing solution. So with my great pleasure, I invite Dr. Kaneeka Vidanage to start the tutorial today. Over to you, Dr. Kaneeka.
Thank you very much for the great introduction, Dr. Pasan. Am I audible to all of you?
Yes,
Hello?
yes.
Yes.
Okay, so let me, I don't know, I have a small issue in my camera. I hope, I don't know whether I'm visible.
No, that's fine. We can see the slides.
Okay, right. Right. So let me first share the screen. Yes, I hope the slides are visible, right?
Yes, yes, we can see.
Okay, right. Thank you very much. Okay, first of all, I would like to convey my sincere gratitude and regards for inviting me to do this workshop in align with the main conference. So I would like to again convey my gratitude to the tutorial presidents as well as Dr. Pasan, who is a very close colleague of mine. So if we are directly moving towards the topic that we're supposed to discuss. Now, when we are discussing about artificial intelligence, I think a lot of people speak about machine learning, right, or deep learning, those aspects. However, now artificial intelligence is actually identified as an umbrella of technologies. That means the technology umbrella. So machine learning, deep learning, then those are actually very hot topics, but they are actually only a subset aligned within the AI umbrella. We have several other options as well. So, namely, I would raise like things like expert systems, fuzzy logic, nature-inspired computing, right? Under nature-inspired computing, there are so many other options, such as genetic algorithms, then swarm intelligence, simulated annealing, likewise. There are so many options, alternatives available. Now, actually, that is, I would like to emphasize this as one beauty in resolving problems associated with the artificial intelligence domain. Because if one technology is not suited, that's not the end, because we have another plenty of alternatives available. Now, say for an instance, one of the critical bottleneck we face when we are developing applications associated with machine learning or deep learning is we need very large amount of annotated data sets. That's a quite of an issue, right? Why? Because locating large data sets in any domain is actually not feasible. Now, for an instance, if you consider somewhere around 2019, 2020, this COVID pandemic became a global pandemic and a huge issue. But most of the scientists identify it as a new virus. Now, corona category is already existing, but this COVID virus was something new. So there were no enough past data for us to utilize machine learning or deep learning mechanisms, right? So that doesn't mean that is the end of integrating artificial intelligence applications for the mm, research purposes. We have so many other alternatives available. So among those alternatives, today actually my main emphasis is towards on ontological modeling or ontology engineering, right? So now the one of the important thing that we need to keep in our mind is we need to understand this terminology or the concept of ontology engineering. Now, basically, what is an ontology? So, in layman perspective, I would say ontology is a domain conceptualization, right? It's a domain conceptualization. Now, again, you might wonder what is that? That's getting like even more complex. Now, each and every individual, right, since birth up to now, we have gone through different ups and downs in our life. We have acquired different experiences, different specialities acquired through the education. All of these things make each of us unique, right? So if we talk a little bit deeper, the internal neuronal wiring of the brain, which it has another aspect, it's a sort of another deep concept called neuroplasticity, right? So how this brain rewiring occurs, right? So we all are unique, right? We all are unique. So that is associated with our individual experiences, ups and downs and everything, how the neuronal connectivity architecture that has organized in our brain is specific from one to another. That makes all of us are not identical. Sorry, that makes all of us are identical, right? Not generalistic. So similarly, now ontology, right? I use the term, it's a domain conceptualization. So when we are going to create an ontology, one of the important thing is the domain, right? We need to properly understand the domain. Now, what do I mean by this? Now, let's take the same example of COVID-19. So there are no data sets available. So we struggle in using machine learning, deep learning approaches. But one strategy that was utilized in those years within the 2019-20, when patients died from COVID influenza, when the post-mortem is taking place, right, they analyze the lung tissues and the consultants acquire new knowledge how the virus has attacked the lung tissues and the what you call damage that has occurred to the lung, then the rising of the phlegm levels, pneumonia impacts likewise. The consultants, right, maybe a general physicians or pulmonologist or virologist, when they are doing the post-mortem, they acquire a lot of new knowledge. Then, let's say I am a computer scientist, right? So I can basically interview these people and acquire their knowledge, right? Acquire their knowledge from different angles. Pulmonologist might look at this problem in the form of analyzing it as a lung disease. Then virologist might look at it from his or her perspective, right? Then immunologist from another side. Likewise, different people derive their specific orientation on the same problem. So being a computer scientist, I can basically interview these people and acquire their knowledge, right? And I can acquire their knowledge. Then this acquired knowledge, I can convert it into a machine understandable format, right? So we refer it as actually, there are several mechanisms. Give me a minute, my machine got, okay. Now I explained about this, the ideology of AI umbrella earlier, so I'm not going to mention again on that. What has happened? Give me a minute. Sorry for the small technical interruption. Right. So let me share the screen again. Right. Now now this is actually the pipeline I was explaining, right? So I can interview the relevant experts, right? And I am acquiring the knowledge from them. Then actually I can convert this knowledge into a machine understandable format. Now, actually, when we are developing an ontology, it's been composed, we can compose that in different ways. I will list one of the prominent ways. One is RDF, right? That is Resource Description Framework. Then we have another one, OWL, Web Ontology Language, right? Now, all these are actually some advanced versions, I can say, evolved from XML, right? Evolved from XML. You know XML, right? Extensible Markup Language. So, which is itself is highly explainable. So, this RDA, now when we interview these experts, acquire their knowledge, and we model this knowledge, right? Using a tool called Protege, right? I'll show this tool as well. This is the tool, right? So this tool is freely downloadable, right? You can download it from, if you just Google, you can download it. This has been mainly developed by University of Stanford University. There are some other paid versions as well, like TopBreed, and there are several. But this Protege has been one of the widely utilized technique or a tool or a GUI, I would say, associated with developing numerous applications related to the knowledge acquisition from the experts and modeling it. Now, let me try to show you some of the existing ontologies. I think right now this was a very small heart ontology, right? Now that means you can interview cardiologists, right? Extract their knowledge, and this is an incomplete ontology. I will just show you the organization of that, and we can use ontograph to visualize it. So let's see how it's happening. Now can you see? This is the knowledge diffusion, right? Now we were telling this as a knowledge model, right? So now I don't know, I think, can you see my screen? Is it visible? Hello?
Yes, sir.
Okay, right. Now here you can see, right? Now you might wonder where this knowledge is coming from, right? This is about addressing certain heart-related problems, right? Heart-related cardiological issues. So from the point of the diagnosis up to the point of treatment could be medical basis or surgical, right? We can interview cardiologists or cardiothoracic surgeons, and we can acquire their knowledge. So the acquired knowledge, right, can be modeled something like this. Now I was telling about modeling the knowledge. So this is how we model the knowledge. So you were looking at the taxonomical distribution of an ontology, which is functional, right? This is not complete. There are some further aspects to be completed. I was just showcasing what is an ontology in form of a visual perspective, because I was telling acquiring the knowledge and modeling, and I know if you are not familiar with ontologies, it's difficult for you to visualize what the hell this person is talking about, So now I think you have some ideology, right? So we speak with the consultants, domain specialists, acquire the knowledge, and we can model the acquired knowledge in form of with the help of a tool like Prodigy. So this is how that processed knowledge is, or the modeled knowledge is visible, right? So if you look at the backend of this file, wait, let me go to this. Right, so yes, this heart ontology, it's a OWL file, right? So I will just open it in Notepad. So can you see it's a XML derivative, right? Some advanced flavor of the XML, which we refer as OWL. Now we can use RDF, OWL, Turtle. There are different formats. Now RDF is the most basic version, and OWL is somewhat more advanced than that, because that means we can introduce more strong conceptualizations when you are working with the OWL format. Similarly, we have the Turtle format that is actually supporting object serializations. I think you might have studied about the serialization and deserialization, right? We can convert an object to its bytes representation, and we can easily transfer it from one place to another place, maybe through a network. So likewise, this TTL format supports the what you call the serialization requirements. So coming back to my main discussion. So I just wanted to show how this ontology is actually looks like, because we were speaking about that. So we created the ontology, right? So here for the knowledge base is ontology, right? And we can couple an inference engine. Right now, this inference engine, actually, this is another very vast area, because there are so many ways where you can do this inferencing. Inferencing in the sense, asking questions from the ontology that you have developed. So you can do the question asking aspect using Sparkle queries, something, right? SPARQL, Sparkle queries. So that's a one way. Or else you can convert your OWL or the RDF ontology into the first order logic format, or the predicate logic format, and you can get the support of a tool like Prolog, right? For logic programming and reasoning, right? And there are some inbuilt reasoners coupled with the with the Prodigy itself. Can you see here reasoners? I have to activate the reasoners. FAT32, Hermit, then Palette. Different type of reasoners are there, right? So what's the purpose of these things actually? Now, uh, let's say I am a layman. Now, let's say you are a medical student, right? Who are studying about the cardiology, and let's say your lecturer is very busy attending patients or going to surgeries, and you might not be able to meet him or her regularly. So what you can do is, right, one of the nice feature that the advantage of an ontology is, you can you interview the experts, let's say cardiologists or surgeons, get the knowledge, develop the ontology, and you can plug it to an interface like, let's say, WhatsApp or some chat interface. So this non-expert user, you are the medical student, you can ask a question in normal English. So the user interface could be a normal WhatsApp or a specific interface that you have developed. So it will do the knowledge to logic mapping with the help of the inference engine, and the reasoning occurs. So you saw the ontology, right? All these connectivity pathways, we can traverse across these pathways, right? You can travel across these pathways and acquire specific knowledge as per the question you asked, right? So there's another advanced concept called upper ontologies. That means now when you have a very large ontology, you don't have to traverse across all these paths because that is a computational overhead, no? So upper ontology decides which region of the ontology to be queried. Let's say if it is from somewhere in this area, so it will the traversing will occur only within this area rather than going across everything. So then it identifies the area to be reasoned, acquire the reasoning happens, acquire the knowledge, convert it into natural language formulation, and provide it to the end user. So this information provided is actually quite highly reliable. Why? You develop this ontology using via interviewing experts. So it's like indirectly you are getting the answers from your lecturer or the consultant, because consultants' experience knowledge has been replicated through this technical platform, right? So that's a one example. Actually, there are ample of examples that I could locate, because not only in the medical, legal, then farming, right? Automobile, you name a domain, to any domain you can use ontologies, and you can do some solid level of reasoning, right? So that's the high level ideology of this concept, how this is going to work. So let's further discuss about that. This AI umbrella concept I discussed. Then we discussed about the challenges in machine learning. Now, you need to have large data sets. Just having a data set is not enough. Why? You need the data set to be annotated as well, right? That means labeling is a must. Otherwise, the knowledge will not be derived if we are going with a supervised strategy. And one of the, I'll come to this black box issue, then in machine learning setups, we have this overfitting and underfitting problems. So when you came across an overfitting or an underfitting problem, it's not that easy to resolve it, right? You might have to do a lot of hyperparameter tuning or data augmentation, or if it is a deep neural network, the architecture adjustments has to be done. It's not that easy, right? Then likewise, and you need quite powerful hardware also to process, because we are speaking of maybe gigabytes of data, right? And to process that as well, you need very powerful hardware or cloud support. So then that is becoming very costly as well. And the data privacy issues. Sometimes if it is healthcare or privacy related, people have second thoughts in providing the data as well. So there are so many challenges. But when it comes to the ontological modeling, all those problems are resolved to a reasonable level. It's very lightweight, right? Maybe on a average level ontology file might be several kilobytes, right? Or few megabytes. I don't think it will go for gigabytes level. So very lightweight. So it supports faster processing. And on top of all of that, the explainability, it's a very, very vital advantage that we are experiencing, the explainability. Now, in machine learning, deep learning approaches, this black box operation is a quite of an issue, mainly in deep learning models. Now, imagine you are using a complex deep learning architecture for a healthcare related classification or decision making. Now, if something went wrong, the prediction went wrong, what will happen? It might be the cost of a life of a person sometimes, right? And we cannot reverse engineer and identify why this error occurred and where this error occurred. Traceability is quite challenging. Of course, now there are solutions developed for that using SHAP, LIME, different technologies are developed. But this explainability of deep learning architectures has become a quite hot research topic these days. However, when it comes to the ontological models, you can see, right, we can visualize the taxonomy. Right, we shall visualize the taxonomy, and it's highly explainable, highly transparent. Or if something went wrong, you can analyze the taxonomy and identify what went wrong and where it went wrong, right? So you have so many advantages in that aspect, right? And the scalability is also very easy, right? Very easy because, for a properly tuned machine learning or deep learning model, when you add new data, again, fine tuning is quite of an hassle, not that easy. But in a what do you call, in a ontological setup, you can easily keep integrating new branches and expanding the ontology. So the scalability is very high, right? So therefore, there are so much of advantages over those. Now, another important concept that we come across when we are dealing with ontologies are competency questions. Now, this is a very important point. Now, competency questions in the sense, when the ontology is developed, to what it should be answerable, right? So you have to plan that before developing the ontology, right? When this ontology is developed, to which areas, to what questions it should answer, it should be answerable. So that is a very important aspect, right? So that ideology is accomplished through this concept of competency questions, right? Now you might wonder how to do these things, where the ontology development methodologies come in handy, right? Now, I was telling of a sort of a complex process, right? Identifying the suitable domain specialists, interviewing them, then recording all their viewpoints, then analyzing the viewpoints and determining the competency questions, then converting the competency questions into the taxonomical structure of an ontology, then injecting the knowledge to the taxonomical structure of the ontology and improving it to the level of an ontology, right? So likewise, then finally validating the ontology, Likewise, we have a quite often comprehensive process. So how I follow that process, how you follow that process, how another person follow that process, it cannot be localized, right? Then it's going to be problematic. So that's why we have standardized ontology development methodologies, right? One of the widely used, very famous methodology is methontology, right? Methontology, not methodology, methontology. So I request you to maybe refer ChatGPT or some other tool and get some understanding about what is methontology, right? It gives you steps that you need to follow, right? Then again, this ontology development methodologies are divided as second generation and third generation. Now, in the second generation ontologies, development methodologies, you acquire the knowledge from the experts, right? And you develop the ontology. You, in the sense, ontologist, right? The computer scientist or the software engineer, we refer it as ontologist, right? So the sole responsibility of the developed ontology lies on the hands or the shoulders of the ontologist. Now, this causes some legal issues. Why? Now, say for an instance, let's say you are developing an ontology for a medical domain. So the medical doctors are explaining some complex concepts to you, and you model it in the way as you understood it. But how you understood it might not be the accurate way. And when you put this to the production, sometimes it's not working as expected. So where it might providing you wrong information, wrong decisions, so which is quite problematic. So where just to overcome that problem, the third generation methodologies are introduced, where this diligent and AMOD are quite famous techniques, methodologies. Now there are this ideology of shared ownership, right? Shared ownership. Now what do I mean by shared ownership? Once an ontology is developed, it's not the sole responsibility of the ontologist, both the domain specialist, right? Domain specialist plus the ontologist, both of them are responsible, right? So that's the latest concept now which is being utilized, which emphasizes on the shared responsibility, right? So okay, now I explained about the shared ontology concepts, and I explained about the RDF, OWL, and sparkles slightly, and these are some other important terminologies that we need to address in detail. So that was the first section, right, which I was trying to emphasize on establishing the understanding of what is ontology engineering if you are listening about this topic for the first time, right? So before I move into the other aspects, I am open to any Q&A if you have any doubts to be cleared or anything. I can share this slide through Dr. Pasan later. Any doubts or anything to be resolved before I move to the next part? Was it clear to all of you what the idea that I was trying to establish? Is it clear? Hello? Hello? I think I'm audible, right?
Yeah, audible.
Okay. Any questions?
I encourage the students. Students can ask the question, no? The third years, fourth years, those who are working on research, you can ask your question, research areas. We can carry out your research project, no, in this area. So, Assam, Imran, Darshini, you can ask questions.
Okay, right. Maybe it's crystal clear that they have no questions. So I'm happy about that.
Inside.
I will give you a high-level overview about working with Protege. Right? Now, sorry about that. I think I'll open. I have a small, simple example. This heart disease one is quite complex. I had a simple one somewhere. Let me close this. Let me reshare. Now, when you are planning to use Protege for your reasoning purposes, you need Java. Java has to be installed. Please keep that in your mind, right? And I'm opening the Protege, right? So this is the initial window that you will be getting, and so you need to accomplish classes, properties, object properties, data properties, individuals, and ontograph is the visualization. So just let me show you, right? Let me quickly open up a simple model that I had, I guess, where test RDF, I think. Yes, let's see. Now, can you see? This is a very simple ontology.
H1 take 2 up to xn. This is correct. Okay. You have to find.
Hello? Hello, is there any question?
No, I think somebody is talking middle of, I think.
Okay.
What's the name of this software?
This is Protege.
Protege. Okay.
Yeah, you can download it free of charge.
It's free, open source, no?
Completely free. Yes, free. It's if you just Google for Protege, you can download it. But before installing that, you have to make sure the Java is installed and environmental variables has been properly set.
Okay.
Now here, now this is a very simple example. So basically, I am creating the classes, right? Here you can click on here and you can put a name and create a class. So thing is the root. It's like the world because we are speaking about conceptualization, right? So in this world, I have two things, modules and people. Under people, I have lecturers and students. Then under modules, I have computer science modules and maths modules. So you can easily click on these icons and add new classes or delete them accordingly. So first thing is creation of the classes. Once the classes are created, you need to add the data properties. Now I will provide you an explanation at a high level because this is a quite of a vast area where usually a model that is running for about one semester. So I'm just trying to give you a high level overview. So data properties are actually used to describe, right? It's used to describe your requirements. Now here, I am just providing data properties for first name, last name, module ID, staff ID, student ID, likewise. So you can see each of these data property is belonging to a class. So that is what in the right side we specify it as the domain. Domain in the sense the ownership. Now, first name and last name, they are actually owned by the people class, right? Then the staff ID and the student ID, can you see? They are owned by the stu ID owned by the student class and staff ID owned by the lecturer. But F name and L name are owned by the people class because both lecturers and students they have names. So can you see the class hierarchy? We have an inheritance here. Okay. So similarly, the modules and the module IDs have been mapped, right? Right. So data properties are for describing. Then the other thing is the object properties. Here, for the ease of understanding, we have added two data properties. Now, data properties are object properties are used to map two different classes, right? Because otherwise, the for the reasoning, you need to traverse across the knowledge model. It's like a graph, right? So class to class, if classes are isolated, we cannot do this mapping. So something like foreign keys in basic databases. So we are using these object properties to map two classes. Now this lectures object property, can you see? It has a domain and a range. Now domain is the owner. Range is the other contact point, connectivity point, right? Now lecturers actually lecturing a module. So can you see the lectures object property has maintain a connectivity among the two classes, lecturer and the module. Similarly, the studies, right, that is belonging to the student class and it maintains a correspondence or a connectivity with the module class. So you can see the connectivity. So data properties are for the object description. Object properties are for object interrelational mapping that is needed for the ontology's traversal purposes. Then we have this concept of individuals. Now, this is another important concept. Through individuals, actually, we are mapping the knowledge, injecting the knowledge to the ontology. Until the knowledge is injected, it's not an ontology, it's a taxonomy. So up to this step, we were just defining the taxonomy. Then from this taxonomy, you can see we can define individuals, or practically it's like objects derived from the classes. Now let me take one by one. Now let's say I have taken I have created an object call or an individual call lect1. And for this lect1 object, can you see I am mapping the knowledge now? What is the first name? I have given my name. Then the staff ID, I have provided the staff ID, and the last name I have provided. Then can you see the object mapping? Now, lect 1 individual, that's myself. I am lecturing M2, CS2, CS1 subjects, right? Can you see the mapping is taking place now? Then if you take what is M1, M1 is actually a regression. M2 is probability, right? And if I take the student 1, right, student ID, okay, some name, this student studies subject M1, CS2, CS1. Now, I hope you will be able to understand through these individuals, I will be in a position to do mappings, right? Do mappings. So when I do the mappings, actually, this knowledge paths are being created, right? So these paths are very important for the what do you call knowledge, reasoning, and the traversal to take place, right? So this is how we developed an ontology. I explained it at a very high level, right? So this is using a tool. Using programming also, we can develop the ontology. So now if I go to where? Now PISA ontology. Now, right, this is an ontology created on PISA, right? There are different PISA items. Right? PISA, different PISA items are there. And this SWRL, actually, I'm sorry, I didn't discuss. It's another advanced concept, semantic web rules. So which goes hand in hand with ontologies. Now this ontologies, multi-agent systems, large language models, right? They are actually working very closely, right? It's a vast area. So here you can actually create an ontology programmatically as well, because sometimes computing people, they like to design the ontology through programming. But medical doctors, farmers, bankers, they cannot understand this, no? Then the created ontology can be visualized through the protege. Then we can get their feedback and modify our code accordingly, right? So this is a automated pizza ordering ontology, right? You can order a pizza and it handles the communication and the reasoning. And ontologies are ideal for stop LLM hallucination, right? I think you might have heard of the hallucinations, where LLMs sometimes try to give non-existing information as existing, right? Because it's generative AI. So we can control the hallucination of the ontology LLMs via coupling them with ontologies. I think you might have heard this RAG architecture, right? Retrieval, augmentation, generation. So likewise, I think there are so much of aspects to be discussed. But I think now we have reached to the time span of 1 hour, and I will share some practical tutorials on this with Dr. Pasan. So then through Dr. Pasan, I think this could be distributed across the participants. So it's a vast area and you can do so many things and it has so many advantages and it can easily coupled up with LLMs, deep learning, which will allow you to get the hybrid intelligence. Yeah, so the purpose of this talk is actually just to provide a high-level overview. I hope you all will agree with me that within a time span of 1 hour, we cannot actually traverse across a large subject discipline, right? I think with that, I thought of winding up. And I'm ready to take up any questions if you have.
Thank you, Doctor. That I would just want to know that for the final year students, what are the projects they can carry it out from this area? So some examples, if you say some ideas, then we can them to carry out.
Yeah. Now, at a surface level, I would say it's limitless. You can apply ontologies to any domain. Where if it is on purely ontological engineering, you can apply for areas where you don't have data sets, but you need intelligence. That's one thing. Then you can couple up ontologies with machine learning or deep learning just to stop it's giving maybe wrong predictions or the machine learning or the DL models behaving unexpected manner than you anticipate. If you develop a chatbot, if it is giving, let's say, a very irrational or I would, let's say, in layman view, let's say, stupid answers. So you can couple an ontology with that, which contains the domain knowledge, and you can make it intelligent and domain oriented and rational. And you can easily couple this with multi-agent systems. So you can have different agents, and from the agents, the inputs are being captured and it's being provided to the ontology, and ontology access the brain for decision making and for the collaboration of the agents. So I think there are so many ways you can use this.
Okay, thank you. Another one question, is it possible to integrate ontology with the deep learning?
Definitely possible, yes.
So here also we have to do the training like in ontology also, like in deep learning we have to do the training.
Now in ontology there is no training part, only interviewing the domain experts or reading the related domain related books, extracting the knowledge and injecting it to the ontology through individuals. No training part. Training part is needed only for the deep learning. Then you can couple it to work as a one combined package.
Thank you. Thank you. Student side, you can ask questions.
Yes, sir.
Yes.
Yeah, sir. What is the difference between the one system use explainable AI or and other system use ontology? What is the difference between the outputs?
Actually, explainable AI in the sense a benefit that you are getting by using a technique like ontologies. It's not another system. If you use a deep learning mechanism, if something went wrong, you cannot trace where and what went wrong. But in an ontology-based system, if something went wrong, you can traverse back and check what went wrong. So the model is very transparent. So that is why we refer it as explainable. So explainability is not a system, it's a feature that you are getting based on the technology you are using.
Okay, thank you, sir. So I
Okay.
use ontology and explainability AI in same system.
Explainable AI in the sense Puta an outcome. If you are using ontologies, you will be having explainable AI within it.
So can you explain more in?
Explainability in the sense you can now, if let's say a prediction went wrong in a deep learning model, can you identify why it went wrong? Let's say if your data set is also quite balanced, very difficult because in a complex architecture, let's say ResNet or efficient net, it has so many layers and so many computations are going on internally. You don't know which line is triggering the wrong answer. So where the behavior is a black box. But in ontology, it's a visible taxonomy, as you already saw in the Hart ontology or the university ontology. So if something went wrong, you can easily identify and you can do the correction itself easily.
Yeah, okay, so now I understand.
Okay.
How to validate the ontology results? Is there any specific metrics they use?
Yes. There are specific matrices as well. Other approach is inviting the domain experts to see whether the answers provided by the ontology is corresponding and mapping accurately with the answers provided by the experts. If a expert is telling this person is having diabetics, and if the ontology is also telling the same results, so we can conduct several case studies, reasonable number, and we can validate the ontology.
Thank you very much. This presentation is very informative.
Okay, thank you very much. So I hope there are no any more questions.
Student size? Any others?
Is Dr. Pasan available?
Dr. Person disappeared. Maybe he told he has an exam duty, maybe.
Maybe. Okay then. Okay then. Thank you very much for inviting me, and it's a pleasure to contribute. And if you want any further information, actually, if you Google my name, my contact details will be available in the internet, and maybe we can look for research collaborations, and there are opportunities.
Okay. So I'm Dr. Jahan. So if my undergraduate students start any projects, that one can you?
Yes. We can actually contribute.
Okay. Thank you. Priyadarshini, now you can.
Thank you very much, Dr. Pashan, and heartfelt thank you to our esteemed speaker, Dr. Kaneeka Vidanage, for delivering such an insightful and inspiring session. Your expert knowledge and engaging presentation have certainly deepened our understanding of ontology development and its application in the modern AI landscape. We sincerely appreciate your time and contribution to ICAIDS 2025.
Okay, thank you very much.
As a token of our gratitude and appreciation for sharing your valuable knowledge and time with us. I am honored to present this token of appreciation to Dr. Kaneeka Vidanage on behalf of the ICAIDS 2025 Organizing Committee.
Thank you very much.
Thank you very much, Dr. Kaneeka, for your remarkable contribution to this tutorial session.
Okay then. Thanks a lot.
Before we conclude, let's capture this memorable moment together. Could everyone please turn on your cameras? Okay, I will count down from 3, 2, 1 and say cheese. 3, 2, 1, cheese. Priyadarshini, can you please confirm that you have captured the moment?
Yeah, Atifa, I got the screenshot.
Okay, thank you all. Engineer A.L. Fatima Sanas, lecturer in Computer Science and Engineering, Department of Computer Science and Engineering, Southeastern University of Sri Lanka, to deliver the vote of thanks. Over to you. Engineer Fatima Sanas.
Yes, thank you, Atifa. Okay. Okay, good evening, everyone. As we conclude this tutorial session, it's my pleasure to deliver the vote of thanks on behalf of the ICAIDS 2025 Organizing Committee. First, our sincere gratitude goes to Dr. Akbar Jahan, Conference Chair of ICAIDS 2025 and President of the Computer Science section of the SLAS East